Hello everyone, welcome back. Yesterday we talked about how to use our part-whole relationship to solve some word problems. Today we're going to be practicing that again. So as we read these problems, I want you to think about what is it asking us to find. Our learning target today is I can solve for unknowns in a story problem using models and an equation. Ready? Let's get started. Before we begin, make sure that you have your counters or cubes, your manipulatives that you're going to be using, as well as your part-whole mat or your number bond mat. Those will come in handy when you're trying to figure out these parts and wholes. All right, let's read our first one. There were 8 birds in a tree. Some flew away. Now there are 3 in the tree. How many birds flew away? Well, let's think. What do we know? We know that there were 8 birds in the tree. So I know that there were 8 birds. Some flew away. Is some a number? No. So what do we do, guys? When we don't know the unknown, we put a box around it. Now there are 3 in the tree. That now tells me what I'm left with. And now there are 3. So let's think, how would we set up this problem? If there were 8 birds in the tree and some flew away, now there are 3. Well, if I listen to my clues, it said some flew away. So am I going to be adding or subtracting? Think, did more birds come or did birds fly away? You're right, we're going to be subtracting. So I might say there were 8 birds in the tree. Some flew away because I don't know how many flew away. Now there are 3. So there were 8, some flew away, and now there are 3. Using your manipulatives and your part-whole mat, pause the video and see how you can solve this problem. How many flew away? There were 8, some flew away, and now there are 3. I'll give you a minute. Pause the video and then hit play when you're ready. I heard some great thinking. So if I know there were 8, I'm going to start off with this model. I'm going to show that there were 8. There are my 8 birds. If I know that there were 8 birds, and I know there's not going to be more than 8 birds, I know that that 8 must be my whole. Because I always start with my whole number when I subtract. That must mean that the 3 is one of my parts, and the sum is the other part. So I know there were 8, and I know I'm going to end with 3. So let's think. If I know that these are the 3 that I'm going to end with, I'm going to go ahead and color those in. I could also draw my line. So if I had 8 and I minus something to get to 3, I could think of 8 minus 3 equals the sum. Because I know that they're interchangeable. This is my whole, I minus a part to get the other part. This is my whole, I minus this part to get that part. So if I had 8 total, and I know I'm going to end up with 3, I went ahead and colored in the 3 that I know. How many flew away? Let's count them. 1, 2, 3, 4, 5. So I know that 8 minus 5 equals 3, and 8 minus 3 equals 5. Now let's think about part-part whole. We said in a part-part whole math, what is my whole in this problem? There were 8 birds in the tree, some flew away, now there are 3. My whole must be 8 because that tells me how many birds I have. I know that now there are 3, so I know one of my parts is a 3. We can take we can take the whole minus one part to get the other part, but we can also think about how to add our 2 parts together to get our 8. So I might start at my 3, and I'm going to use my counting on strategy. 3, 4, 5, 6, 7, 8. How many birds must have flown away? There were 5. Because 3 plus 5 equals 8. And 5 plus 3 equals 8. I always box what I found out because that is my unknown. Another way that you can figure out this problem is always to use a number line as well. So let's try that model. Again, I know that I had 8 birds, and I know I'm going to end with 3. So let's see if we can figure out the other part. I'm going to start at 8, and I'm going to count back until I get to my 3. 1, 2, 3, 4, 5. I stopped at my 3 because that is how many were left. If I count my hops, I knew that I subtracted 5. I could show that 3 is the part I knew, and I could add 5 to get to my 8, because 3 plus 5 equals 8. 8 minus 5 equals 3. It's great how those numbers work together in their family. Let's try another problem. Make sure you have your tools with you to try and solve. Robbie had 4 toy cars. Well, we know he had 4 toy cars. His dad gave him some more cars. He gave him some more. Do I know how many he gave him? No, I don't, so I'm going to put a box there. Now he has 7. How many cars did his dad give him? So let's think through this problem. How would we set it up? Robbie had 4 toy cars, and his dad gave him some more. If he gave him some more, then I think my number's going to get larger, that he's getting more cars. So I think that if he had 4, and his dad gave him some more, that means I'm going to be adding. Now, he has 7. So that means that is how many I'm going to end with. Let's think about labeling a problem. I know that my 2 parts go together to make my whole. So my whole must be 7. And my 2 parts must be the 4 and our mystery number. With your manipulatives and your counters or cubes, I want you to take a minute to see if you can solve for the missing number. 4 plus what equals 7? pause the video, and when you're ready, press play. Great job, mathematicians. So I heard a lot of great thinking and I saw lots and lots of models. I went ahead and set up a few of my models on my chart. And now we're going to share out how did we use those models to help us solve. Well, I know that these two are my 2 parts and 7 is my whole. So I'm going to fill in my part whole mat. My whole was 7, so I'm going to put it right here. The part I know is 4, so I'm going to fill in my other part. What I don't know is how many did he give him to get to 7? How can I figure that out? Great job, guys. You can count on. So here's 4. Let's count on. 5, 6, 7. I stopped at 7 because that's my whole. This is a part and this is a part. So how many cars did his dad give him? He gave him 3 because 4 plus 3 equals 7. I can show that same thinking with a number bond. I know my whole is 7. The part I know is 4. I can use my counting on skills to help me with this. Here's 4, 5, 6, 7. So that still leaves me with 3 that his dad gave him. Now remember, your parts go together to get your whole, but your whole can also minus a part to get the other part. So I could have thought 7 minus 4 equals my other part. I could show that with counters. I could draw 1, 2, 3, 4, 5, 6, 7. I can minus out 4. And that leaves me with 3. That's just another way that I could solve this problem. One of my favorites that I saw was a number line. Again, my whole is 7. So I know I'm not going to go any larger than that 7. I know the part that he had was 4. So I'm going to start at 4. And then I'm going to count on until I get to 7. 4, 5, 6, 7. So I added 3 hops. 4 plus 3 equals 7. And I could also think 7 minus 3 equals 4. That would still get me my answer. 7 minus something equals 4. Great job with your thinking today. As you're continuing to practice, think about what the problem is asking you. For the unknown, always put a box, so that way you know you're trying to figure out that number. There are always clues in our word problems, like the words some and now, or more, or gave away. All of those gave us a clue as to how to set up our word problem. Good luck trying to be detectives. Continue working on your word problems. Have a good day.